Welcome to Algebra 2, Lesson 3-6, Example 4, Interpret the discriminant. In this example, we will look at a word problem and try to interpret in the context what the discriminant means in the context. So let's look at this example in example 4. Rachel is about to serve and tosses a tennis ball straight up into the air. The height h of the ball in meters at time t in seconds is given by h of t is equal to negative 5t squared plus 5t plus 2. Will the ball reach a height of 4 meters? So we have the equation for the height of the ball. We want to see if the ball would reach a height of 4 meters, and that would probably depend on what the vertex is, because the vertex would give you the maximum point, right? To see if h equals 4 for some value of t, set the quadratic equation for h equal to 4, right? So this whole equation is equal to 4. And then you can change that to 0 by subtracting 4 on both sides. And you get negative 5t squared plus 5t minus 2 is equal to 0. And now we have a standard form. So we can identify A, B, and C. A is negative 5, B is 5, and C is negative 2. And we learned about the discriminant in the last example, right? So if we figure out the discriminant, B squared minus 4AC, then we know what type of solutions we'll have, right? So first figure out the discriminant, and that would be negative 15, which means you're going to have non-real solutions, right? So when the height is 4, it doesn't have real solution, which means your vertex will not be as high as 4. So the ball will not reach 4 meters. So this is another way to solve, because you can plug in and solve for the entire thing, but this is a shorter step to solve this problem, right? So we want to know how to use and interpret the discriminant in context like this. So if we see anything like, oh, will this be enough, or will it reach this much, right, or something like that, then we can always check the discriminant in quadratic formula to figure out if it's going to have a real solution or not. If it has real solutions, then yes, it will reach that goal, or the ball, in this case, the ball would reach a height of 4 meters. But if you have non-real solutions, it'll not. So at the end, you want to interpret your solution and say, so the equation h equals 4 does not have a real solution, and so the ball does not reach 4 meters. So instead of solving for your roots and your t, you can just check discriminant and figure this out. So it makes your life easier whenever you see this type of problems. So let's look at try number 4. According to the model of Rachel's serve, will the ball reach a height of 3 meters? So pause the video and come back when you're ready for answers. Okay, so are you ready? We're looking at the same equation, right? H of t is equal to negative 5t squared plus 5t plus 2. Let's write the original equation. Okay, so according to this model, it's going to be the same model. Would the ball reach a height of 3 meters? We're gonna use the same method. Instead of solving for your t's all the way, we're going to see if h that is equal to 3 would have real solutions, right? So if h is 3, then we will have real solutions for this equation, right? So let's figure that out. Again, you're going to subtract 3 on both sides to make this equation into a standard form. And so you would have negative 5t squared plus 5t minus 1. And then you will find the discriminant b squared minus 4ac. But first, let's identify a, b, and c. A is negative 5, b is 5, and c is negative 1. Your discriminant equation is b squared minus 4ac. And that's equal to 5 squared minus 4 times negative 5 times negative 1. And that's equal to 25 minus, because negative, 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 if you multiply negative 3 times, it's still a negative, right? 20 times 1, 20, and that's equal to 5. Yay! So there are 2 real solutions, which means when you have a height of 3 meters, you'll have 2 real solutions. So that means it's still not a vertex. It's not one solution, right? That means your height of 3 is somewhere over here. So one of the solution would be still when the ball is still going up. The other solution represents when the point where the ball is coming down. So let's write this in the context. Yes, we're gonna answer this question. The discriminant is 5, which is greater than 0. So there are 2 real solutions. Therefore, there are 2 times at which the ball will reach a height of 3 meters. Okay, so that's what it means in this context. All right, so in example 4, we looked at a word problem in a context where we could use discriminant and interpret discriminant to figure out our solutions easily. Let's continue with example 5 in the next video.